Alright, this is an overview of our first two ionic naming systems. Okay, and what I mean by that is the binaries. Okay, our two binary systems. Okay, binary being a compound or a formula composed of two different atoms. Alright, so the first one I'm going to talk about is the representative metals with a nonmetal. Alright, and this is probably the easiest system we have. Okay, the representative metals. And for all of our naming systems, we have to go back and forth. What I mean by that is you're going to be responsible to get to the name from a formula and also to get to a formula from a name. All right, and like I said, these are the very easy ones. There's no special tricks. It's basically just label what you have. Okay, the only thing you change is the ending of the negative ion. Okay, gets turned into IDE, IDE. All right, so if I do this one, it's Ca, which is calcium. Okay, so it's calcium, and it's not calcium bromide. I'm sorry, it's not calcium bromine, it's calcium bromide. Okay, so the INE was switched to an IDE. And that's basically all there is to it. Okay, you just pick any one of these. You have to know what the symbols mean. Ag is silver, so this one's going to be silver. Don't change anything on the metal. Silver, and then S is sulfur, and we don't report that as sulfur. We report it as sulfide. And you can see that once you get good at these, you can do them extremely quick. Okay, as long as you know what the symbols are. Barium is Ba, O is oxygen, oxygen is oxide. It's a little bit more difficult, and it always is, in order to get from the name, okay, to the formula. And that, for that reason, we actually have this scrap column. All right. Well, we already did silver sulfide. It's right there. Picking up one, I'm going to say aluminum chloride. So it's an aluminum and a chlorine coming together as ions, aluminum and the chloride ion. And in order to have the ratio, the population numbers, the ratio of how many aluminums and how many chlorines I have to do some investigating. All right. The whole goal is to have a neutral compound. And it's just as easy as looking up the charges on the periodic table. And you're going to see that it's plus 3 minus 1. And we know these charges because both of these are representative elements. What I mean by that is their charge is actually represented by the position in which they actually occur on the periodic table. What I mean by that is there's no guesswork. It's not an unknown charge. We actually know the charge. So it's as easy as just looking it up, labeling it as plus 3 minus 1, and then figuring out in order to have achieve neutrality, it will be AlCl3. Okay, meaning you would have to have 3 Cls, and if I was keeping track, I'd have to have 3 Cls to have negative 3, and that will offset my positive 3. The whole goal is to use your figuring skills in order to figure out a lowest common multiple. Okay, LCM. You have to figure out a lowest common multiple and then just achieve that lowest common multiple with the subscripts, which I refer to them as a population number, meaning how many of those chlorines you would have. Okay, and it'd be 3 to 1. And these are a little bit of a slow motion at first until you get a feel for the actual periodic table, you get a feel for the charges, and that starts to make life a little easier. just to pick another one, lithium phosphide, which is phosphorus, LiP. Okay, looking up their charges, I have a +1, a -3. In order to be neutral, my formula is Li3P. Okay, so it's all charge base, and again, these are the representative elements. All right, now that was the easiest form of naming we have, and at least for the time being. And we're going to make that just a slightly harder. We're still in the binary realm. Okay, so we're still in the binaries, which are, of course, the two atom or two element systems. Metal, nonmetal, but this time we're not using a representative metal. We're using an unknown metal charge. What I mean by that is when you have your periodic table, okay, when you have your periodic table, we have so many elements that we know the ionic charge that develops, okay, or they develop. We have so many specifically on the metal side that we don't know, and that would be what we're talking about here. I can't flip this, but the periodic table I'm referring to is like this. I realize it's sideways, but we have our +1s, +2. Those are representative. Our -1s, our -2s, -3s, -4s, -5s, they're all representative. And then my +1, +2, and +3, all representative. All right, and we have a system where we know all of the negatives at all times. Okay, so it's never any guesswork for the negative component. But the metals, actually we only know a fraction of the metals. Okay, we only know the first two columns, and then the silver, zinc, aluminum interchange here. All the rest of the metals have unknown charges, because they actually can have, it's possible they can have more than one charge. And that's where we have to actually be a little bit more specific. All right. Now, we do that with the stock method. And the stock method is just a way of showing the charge of the metal with a Roman numeral. Okay, the Roman numeral does not go to the bromine in this example here. It doesn't go to the bromine, it goes to the copper. It's the copper's charge. We already know bromine's charge. It's always -1. Okay, copper is actually variable. It can be +1 or +2. They're specifically saying copper in this case is +2. So when you're actually writing the formula, this is routinely called the little bit harder system, the stock method. Okay, the stock method of using the Roman numerals. When you're writing the formulas, it's actually it's easier. You don't have to look them up. They're giving us the metal charge, so we don't have to look that up. We only have to look up the negative component. And it's Cu +2. I'm getting that +2 from the Roman numeral. Bromide, which is bromine, you look that up and you see it's -1. So my formula will be CuBr2. Again, the same reason as before. I have to achieve a neutral compound here. So in order to do that, I have to have 2 bromines for every 1 copper. We'll just do one more. Antimony. What antimony am I talking about? Talking about antimony +3. Why do I know that? Because it says Roman numeral 3. Sulfide, -2. Takes a small bit of thought here. Where's my lowest common multiple between a 3 and a 2? We're going to meet at 6. And meeting at 6, I'm going to have Sb2, S3. All right, so when I do that, I'm going to have, if I was keeping score at home, a -6 and a +6, and I'd be neutral. Okay, it's good that we have this checking mechanism whenever there's any doubt. So writing the actual formula from the new method of the stock naming, okay, and again, we use the stock names for the rest of the metals that are not representative. Okay, writing the formula is actually fairly simplistic. It's actually easier. We get into a little trouble though when we have to write the names from the actual formula. That's when it gets a little bit more difficult. You can hear the dog barking in the background. Okay, so notice on a lot of these I have repeated metals. Are you done? Not done? One more? Okay, I have repeated metals over and over again. You can see I have SN, which is tin, twice. I have PB twice, which is lead. SB, which is antimony. Bi twice, which is bismuth. And the negative component, the non-metal, is the same. Right? What I'm saying is the first batch here is they're both sulfurs. So I have tin sulfurs. Okay, so it'd be tin sulfide. So if I was just writing the name, if this is the column, which it is for name, if I write tin sulfide, you can see what the issue is. I have to be a little bit more specific because I just wrote the name as tin sulfide, like we did in our first batch of namings for the representatives, and that's just not good enough because look what happened is I have two different formulas, two different compounds, okay, which are going to have two different characteristics with essentially the same name. And that's a problem. We like to say that tin sulfide actually doesn't exist whatsoever. All right. Doesn't really exist whatsoever. We have to be more specific, and we have to say tin, its charge, sulfide. And this is where we have to slow it down just a bit. Remember, the Roman numeral was the charge of the metal. And I have to do a little bit of investigating in order to figure out the charge of the metal. I always know the charge of the nonmetal, okay, which is going to be the S's. All of our nonmetals are known. They're representative, which what I mean by that is I look up on the periodic table. I have -2s for my sulfurs. Because sulfur is -2, in the first example, tin must be +2. Okay, so I'm going to put a Roman numeral 2 there. Because in order to even out or balance off my -2, it has to be +2. On my second example, my tin must not be -2, but actually, I'm sorry, must not be +2, but instead +4. Why? Because my overall negative charge is -4. I have two -2s, so my tin must be +4 in order to compensate. All right, so it's a little bit of a, you have to investigate it a little bit. Let me pull up some better examples that might be a little bit more complicated. And we like to do that purposely. We pick the most complicated ones we can, because if you know the complicated ones, it makes it's very reassuring that we actually have the concepts down. All right, so I'm going to pick these. All right, we'll do a couple off this page. All right, just a couple more. This is actually a mix. Some of these are representative. What I mean by that is the metal is in the first two columns or on the diagonal. For example, my sodium, my barium, my rubidium, my magnesium, and my calcium. All right. I have a pretty good idea of the periodic table. You might have to look those up, but when you look those up, you're going to find out that those are in the columns for the alkali and the alkaline metals. So we know their charges. You don't need the Roman numerals. for those. Technically speaking, it's not wrong to put Roman numerals in there, but it is a colossal waste of time. So you can just say sodium chloride. You don't have to specify. You don't have to put a Roman numeral and say it's sodium 1. Sodium's always 1. It's representative. Okay, but the rest of them aren't. Okay, the rest of them are unknown metals, which means we're going to have a Roman numeral in there. And you can see that Fe is iron, and S is sulfur, which turns into sulfide. Okay. I have to do a little investigating. Okay, again, I start with the negative and work backwards. I know sulfur is -2. If sulfur is -2, I have overall charge of -6. Okay, and if you really wanted to see my notes for that, let's put them back down there again. I have my -6. What must my charge, is a question mark, what must my charge of my iron be in order to get to +6? Okay, because I have to have a +6 by default in order to be neutral. I have to have a +6. It's almost like I'm working a total U-shape backwards. I'm starting over here and working all the way around. In order to have +6, my question mark must be 3. Okay, because I'm going to have 2 +3s. All right, because there's a little subscript 2. My population number for my iron is 2. So it's going to be iron 3 sulfide. And lastly, we'll do this one last. Lastly, I have my, just to start us off, my bismuth oxide. Bismuth is not in the first 2 columns or on the row of the aluminum silver area, which means it requires Roman numerals. Okay, it's not silver, zinc, or aluminum. It's not in the first 2 columns. So it's a metal of an unknown charge, just like my iron was. And I start with the negative component. It's a -2 again, which means I have a -10 overall. In order to get a +10, I know I have to get a +10. Okay, I know I have to have a +10 on this side. What must my question mark, what must my charge of my bismuth be? It has only one choice, bismuth 5. Because I have 2 bismuths, 5 times 2 gets me to 10. It's a little bit of algebra, it's a little bit of common sense. So, in summation, the representative compounds, you don't need the Roman numerals, which is called the stock naming system. You can just write the name, just like the sodium chloride or my barium fluoride. Okay, but if the metal is not in those first 2 columns, or silver, zinc, or aluminum, then you do have to use the stock system. The stock system is the Roman numeral. It's the charge of the metal. And that handles all of our ionic binaries. So our first 2 naming systems are now complete.